In OpenVSP, the quality and the ease to import in your card system the OpenVSP file depend on some parameters that we're gonna to look after right now. First of all, I remind you that you don't use the export menu in the file system, but you export the trimmed surface in the analyze. That's not obvious. So in the trimmed surface, you have this submenu, this tab, display, output, and this one you don't need. It is important to keep the curve adaptation tolerance tight. Here, this is 1 of a million, 10 power 6. And I generally keep intersecting a subsurface because you want to have your fairing and the fuselage, but you don't want to have this. Because if I'm not intersecting, what will happen? I will have this whole body inside my fuselage. You understand that this fairing is an entire body inserted into the fuselage. And when I am exporting with a trimmed surface, I want the intersection and to keep the outside of the fairing and not the inside. This is why you need to keep intersect subsurface to be checked. The mode surface to cubic, okay, you let this like it is. And it's not really important, but it will show you what he has done. And the most important is here, output. So you want to include the X, Y, or Z. And now you have the choice output some EJS or step file. Generally, I work with step. You need to keep these high step tolerances and very important to set up your units. So it could be imperial or it could be meters, centimeters, meters. So I work with millimeters. But if your project is big enough, you will need some feet or maybe some meters. You have two ways to export. So you can export in surface, in shell, or you can export in solid. To be frank, in Fusion 360, last 6 months, Fusion 360 has been updated. And whatever you do, just use the in-stitch. And whatever it is, a solid or surface menu, you will get back to a surface. So in Fusion 360, it doesn't really matter. And now you just have to intersect and export. What is gonna to help you tremendously if you have some problem of bad surfaces, something like this, in the region of the high curvature, so here in the leading edge of this fairing, and also when you are on the top of the ending surface, curvy surface, it's likely you could retry some problems when you will export this and input in another card system. What can help you is, first of all, you want to have a high tessellation, and the recommendation is around 80. This is a global object from the first tab here, and around 350 for the W. Now, you need to remember that in the X section has also a number of U. So how does it translate? If I am just asking the wiring here, you can see the tessellation. So for example, I ask, let's say 2. So I have lost a lot of tessellation here. If I ask 10, I will have more tessellation. And if I ask what I have asked before, you can see the difference. Each section, you can modify the tessellation for each exec. So of course, when we come along the fairing, I want a very high tessellation to have a lot of information about the most curvy stuff. So that could help you. The second thing is you gonna to have here, we're gonna to open this one. So I remind you that the first 0, origin point is a point. It's an object point, which is the best way to start your body, your fuselage. And in the skinning, I would recommend you to ask 1 for strength. It will help things to be a little more curvy, have less angle. So you can see right now that I will get now with 1 more curvy stuff. It will help him. And that's the same here for this position, this section. So if I put 0, you can see that there is a lot of angle and it's not gonna really to help us. So we want to keep the strength at 1 in this area to smooth and help the curvature. And so for the CAD system, Fusion 364 for me, it will help him to avoid the invalidated surfaces.